In order to adjust the speed valve, you will need the following tools. Diagnostic test fittings, as provided in the Stanley Labalti Digital Gauge Kit, part number 169832. A set of 2 hydraulic pressure gauges, only one may be used if necessary. A set of open, box-in, or combination wrenches, sizes 12 mm to 19 mm, and a set of Allen wrenches, sizes 4 mm to 12 mm. The appearance of the speed valve and the location of adjustments and test ports may vary, depending on the age and model of the attachment. Stanley Labalti recommends that the following safety precautions be taken when adjusting the speed valve. Caution: always wear the proper personal safety equipment when performing speed valve adjustment, including shatterproof safety glasses, insulating gloves for low and high temperatures, and steel-toe boots. Warning: exposure to hydraulic oil can cause burns, or, if injected into the skin, can cause gangrene. If oil is injected into the skin, immediately seek medical attention. There are basically 2 operating conditions that affect the performance of the speed valve and will require some troubleshooting by an equipment mechanic or service representative. These conditions are: the speed valve does not shift into speed mode, resulting in a slow closing movement of the attachment, or the speed valve does not shift out of speed mode at the appropriate time, resulting in a loss of cutting power. Both of these conditions can be remedied by proper adjustment of the speed valve. Warning: speed valve adjustment requires an operator and a mechanic keeping within sight of each other while adjusting the valve. Ensure all others are clear before cycling the attachment. Position the attachment on firm, level ground so the speed valve is easily accessible. Turn the excavator off and release all hydraulic pressure to the attachment by working the excavator controls in all directions. Be certain to relieve the air pressure in the excavator reservoir. Refer to the Excavator Operator's Manual for proper excavator hydraulic pressure relief procedures. Place a drainage basin below the ports to capture all escaping fluid. Slowly remove the plugs from the MBS port and the MAZ port on the speed valve. Turn the plugs counterclockwise until fluid begins to seep from the port. Allow the fluid seepage to slow before continuing. Continue to slowly turn the plugs counterclockwise, pausing momentarily at 1/4 to 1/2 turn intervals until the plug is removed. This ensures all residual pressure is relieved from the speed valve. Install the test fitting supplied with the Stanley Labalti Digital Gauge Kit, part number 169832, into the MBS and MAZ ports on the speed valve. These fittings are -4 SAE O-ring Boss 7/16 20 straight thread fittings. If the MAZ port is too difficult to access for test fitting installation, the MX port on the speed valve may also be used to monitor valve pressure. Attach the gauge and pressure line to the MAZ test port on the speed valve. If 2 gauges are available, install the second gauge and pressure line to the MBS test port on the speed valve. If only 1 gauge is available, the MBS test port on the speed valve must be plugged at this time with the MBS port plug. Have a coworker restart the excavator. Check for leaks in the test fittings by using a piece of cardboard or other rigid material. Repair all leaks before proceeding. Caution: do not make adjustments to the speed valve while the cylinder is extending. Reset the main spool valve adjustment by loosening the lock nut on the main spool valve and turning the socket head adjustment screw counterclockwise. Continue to turn the socket head adjustment screw until the end of its travel is reached. Then, turn the socket head adjustment screw clockwise until you feel the tension of the main spool. After tension is felt, turn the adjustment screw 1 full turn clockwise. Retighten the lock nut on the main spool valve while making sure the socket head adjustment screw remains in place. If the main symptom is that the speed valve is not shifting into speed mode, follow this step first. Loosen the lock nut on the pilot valve. Turn the pilot valve adjustment screw clockwise, 1/2 turn increments at a time, cycling the attachment from fully open to fully closed for each 1/2 turn increment, just until the attachment goes into speed mode. This is the lowest end of your range of adjustment for the speed valve. If the main symptom is that the speed valve is shifting into speed mode but lacking cutting power, follow this step first. Loosen the lock nut on the pilot valve. Turn the pilot valve adjustment screw counterclockwise, 1/2 turn increments at a time, cycling the attachment from fully open to fully closed for each 1/2 turn increment, just until the attachment does not go into speed mode. This is the lowest end of your range of adjustment for the speed valve. Once you have completed one of the previous steps that applies to the problem you're experiencing, the following steps will help you adjust your speed valve to its ideal setting. Turn the pilot valve adjustment screw clockwise in 1/2 turn increments at a time, cycling the attachment from fully open to fully closed for each 1/2 turn increment. Carefully monitor the gauge attached to the MAZ port. As the attachment reaches the fully closed position, the pressure on the MAZ gauge should spike and drop to nearly zero. This means that the speed valve has shifted out of speed mode and the pressure reading on the gauge attached to the MBS port should read nearly full system pressure. Continue to do this until the pressure rises on the MAZ port and does not drop to nearly zero. This is the highest end of the adjustment range and means that the speed valve is not coming out of speed mode. Be sure to keep track of the number of turns it takes to reach this setting. Now, turn the pilot valve adjustment screw counterclockwise 1/2 of the number of turns required in the previous setting. Retighten the lock nut on the pilot valve, while making sure the adjustment screw remains in place. This will bring your speed valve to its median range of adjustment, or ideal setting. Test the adjustments by cycling the attachment to the closed position 6 times normally, and 6 times with the attachment stalled in the closed position. If the previous adjustment procedures do not work, or the attachment is closing erratically in a choppy motion, the seals on the pilot valve poppet may be damaged, or the valve seat itself could be damaged. The poppet valve is located on the opposite side of the pilot valve adjustment screw. Remove the poppet from the pilot valve and inspect the poppet seat and seals for damage. If either the seals or seat are damaged, replace all parts as needed. After the speed valve has been resealed, it will be necessary to go through the previous steps to correctly adjust the speed valve. If the problems persist, the speed valve may require replacement of the hydraulic seals. Seal kits are available from the Stanley LaBounty Customer Service Department. The attachment serial number will be required when ordering. For the fasteners used to secure the Stanley LaBounty speed valve to the attachment cylinder, use the following torque values. For 100 GPM speed valves, part number 513904 and 512506, torque value is 185 foot-pounds, 250 Newton-meters. For 200 GPM speed valves, part numbers 513029 and 512287, torque value is 370 foot-pounds, 500 Newton-meters. For 250 GPM speed valve, part number 511461, torque value is 348 foot-pounds, 472 Newton-meters. Turn the excavator off and release all hydraulic pressure to the attachment by following the proper base machine's OEM procedures. Slowly detach the pressure gauges and pressure lines from the MBS and/or MAZ test fittings. Slowly remove the test fittings from the ports and replace the MBS and/or MAZ port plugs. Restart the excavator. Check for leaks by using a piece of cardboard or other rigid material. Repair all leaks before using the attachment. Reapply the correct torque to all speed valve fasteners, including split flanges, if found leaking. Use the torque table found in the Safety Operation and Maintenance Manual for correct torque values.